Hello, my name is Shoaib Ali, and this is my video project submission for Mr. Fies' algebra class. So to solve this equation, we can use Newton's law of cooling, and we can set it up as the outline, which is T equals TA, which is the ambient temperature, plus object of the temperature at a certain time minus the ambient temperature, all to the power negative KT, which is the decay coefficient for K and time for T. So to go ahead and solve this equation and find the time of death and the time elapsed, we need to find K, which is the decay coefficient first. So to do that, we're going to go ahead and set up the equation as 75 degrees, because that is the temperature of the body at 5 p.m. The ambient temperature of the room is 70 degrees, plus the temperature of the body at a certain time, which at 4 p.m. it was 80 degrees, minus the ambient temperature of 70, all to the power of negative KT. So, if you subtract 70 out of the equation, you're left with 5 on the left side, and then 80 minus 70 is 10, with e to the negative kt. If you divide 10 out of both sides, you're left with 1/2 equals e to the negative kt. And now to get k, we're going to go ahead and take the natural log of 1/2 and eliminate the e and bring down negative kt. So since we have that negative sign and that t, we want that k isolated. So we're going to go ahead and take negative t out of the equation and put it on the bottom of the natural log of 1/2, which would come out to be -1 equals k. And if you take the natural log and multiply and divide that out, that's going to come out to give you k equals -0.693. So now that we have that decay coefficient, we can go ahead and find the time of death and the time elapsed from the time of death. So to do that, we're going to go ahead and set up the equation with 98.6 as the average body temperature of a living human, equals 70 as the ambient temperature of the room, plus 80 minus 70, 80 being the temperature of the body at 4, and then 70 being the ambient temperature, with e to the negative 0.693 times t. So if we subtract 70 out, it's going to give us 28.6 equals 80 minus 70, which equals 10, e to the negative 0.693 times t. Now if we divide 10 by both sides, it's going to give us 2.86 on the left side, and then e to the negative 0.693 times t. And if we take the natural log of 2.86 at this point, it'll bring that negative 0.693 down along with that t. And then we can just divide negative 0.693 from this side along with this side. And if we subtract and or actually multiply all that out, it'll give us t equals 1.516, which tells us that there's about an hour and a half that passed by since the body was originally dead. Hours elapsed. So if we go back about an hour and a half from 4 p.m. we can find out the time of death would be 2:30 p.m. and the time of death, or the time that elapsed after the time of death, would be an hour and 30 minutes. Thank you.